Hey, everybody. So today we are getting into 3.1 dilations. If you guys remember in the last chapter too, we were looking at transformations and we looked at three different types: translations, reflections, and then rotations. Okay, today we're looking at a fourth type of transformation, and it is called a dilation. All right. The reason why this is a little separate from the other I guess, three types of transformations is because these dilations actually change the shape of our graph of our shape here. So that's why it's a little bit separate. Okay, but you'll see it's a really simple idea. So first thing, this PDF that I've attached to it. If you'd like to do this work in Kami, you can. If you'd like to print this thing out and do the work on it, that's also a good idea. Maybe the easiest of the way. And if you don't have a printer or any of that stuff, you can also just do this on a separate sheet of paper, as always. So whatever works best for you. Okay, so yeah, let's go ahead and jump in here. So basically, what a dilation is it's us shrinking or enlarging our shape. Okay, so it's either going to get smaller or it's going to get bigger. All right, and that's kind of it. And you'll see basically what we're doing is we're just multiplying our dilation by our points, and we're getting it. Okay, so let's try it out on number one here. Okay, so this one's asking us to do a dilation of 2. Okay, so here's what we need to do. We first need to start by getting the original coordinates of our original shape here. All right, so let's start. Let's do that real quick. A looks like it's at -1 on the x, -1 on the y. So -1, -1. Okay, B is at -1, +1. And C, +2, -1. Okay, so here's what we need to do. We just need to multiply these points by our dilation. They're telling us our dilation is 2. So that's exactly what we're going to do. We're going to take all of these points and multiply it by a 2. Okay, so yeah, let's go ahead and do it. Easy math here. So to get A prime, -1 times 2 is a -2. -1 times 2 is another -2. Okay, to get B prime, -1 times 2 is again -2. 1 times 2, 2. And to get C prime, 2 times 2 is a 4. And -1 times 2, -2. Okay, and there it is. That's going to give us our dilation. So let's see what happens. So A prime is at -2, -2. To the left, 2, down 2. Here's A prime. B prime is at -2, +2. To the left, 2, up 2. And C prime, +4, -2. To the right, 2. Or sorry, to the right, 4, down 2. Okay, and connecting these dots, we will get our dilation. Okay, and there it is. And you can tell what happened here. It looks like we got an enlargement. We got a bigger shape when we did a dilation of 2. All right, let's try another one of these examples together, and then I'll have you guys try a couple on your own. All right, so take a look at number 2 here. Asking us to do a dilation of 0.5. All right, so again, let's go ahead and get these originals real quick, and then we'll multiply by that dilation. So I'm going to start with P. It's at -2, +3. Q, -2, +4. S, +3, +1. And R, +2, +2. All right, and again, we are multiplying by our dilation, so times 0.5 is what we're doing here. Just remember, 0.5, when we multiply by 0.5, that's the same as taking a half of the number. All right, if you need to use a calculator, that's perfectly fine. You know, you can use there. You can find it on your computer. If you're using a Chromebook, just type in calculator. You can use one on your phone if you actually have a legit calculator. That's awesome too, which by the way, eventually you're gonna want or need a legit scientific calculator. So I would start looking for one when you go to the store. Okay, so anyway, yeah, I'm taking half of these numbers. So half of -2 is a -1. Half of +3 is a 1.5 or a 1.5. Okay, q prime, same idea. Negative 2, half of negative 2 is a negative 1. Half of 4 is 2. Okay, s prime, and sorry, my s's look like 5 sometimes. Half of 3 is 1.5. Half of 1 is a half, or 0.5. Okay, and then r prime, half of 2 is 1, half of 2 is 1. Okay, so there are our points. It's kind of weird, there's decimals here, but again, use your calculator if you have to. So let's plot it. P prime, negative 1 on the x, 1.5 on the y. So that means we're going to the negative 1 up 1.5 right there, P prime. Okay, Q prime, negative 1, positive 2, to the left 1, up 2. S prime, to the right 1.5, up a half. Okay, so yeah, to the right 1.5 and then up a half. That's S prime. And then R prime, right 1, up 1. Okay, go ahead and connect your dots and see what your shape looks like. And feel free to pause this video at any time if I'm going too fast. All right, so as you guys can see on this one, we got a reduction is technically what they call it, but we got a smaller shape. Okay, so real quick, let's make some sense out of this. On the last one, we got a bigger shape. On this one, we got a smaller shape. Why that happened? All right, you can probably, kind of deduce what happened here. It all depends on whether our dilation is a number greater than 1 or less than 1. Okay, when you get a number greater than 1, like 2 on number 1 here, you're going to get an enlargement. When you get a number less than 1, like 0.5, you're going to get a reduction. It's really that simple. Okay, always a good thing to keep in mind, just so you can expect to get a certain shape while you're doing this. Okay, so I'm going to have you guys go ahead and try out numbers 3 and 4 on your own. Okay, so go ahead and give number 3 a try first, and then we'll move to 4. Okay, so for the sake of saving some time, I'm going to leave this one to you. Go ahead and try out number 4 on your own. Okay, and again, for the sake of time, I'm going to leave these to you because I don't want this lesson to be terribly long. All right, but as you guys, should have expected on number 3, you should have gotten an enlargement. You probably got a shape. I'm just kind of eyeballing it. Probably something that looked like this. Much better than that though. Okay, on this one, you probably got a shape that looks smaller, maybe something that looked like this. All right, so sorry for skimming over those, but I'm sure you're doing fine. Okay, so let's move on to some problems that are given as dilations in the context of ratios or fractions. Okay, it's the same idea. We're still going to multiply it. Don't be afraid of the fraction. Let's try out number 5 together. Okay, so let's go ahead and get these original points. V's at negative 1, positive 2. U, negative 1, negative 2. W, positive 2, positive 2. X, positive 2, negative 2. All right, and we are multiplying these by 3 halves. All right, here's a little reminder, guys. When you multiply just a normal looking number like a negative 1 times a fraction, okay, what you're going to do is multiply that number times the numerator, the top of your fraction, and then divide by the denominator. Okay, and we're going to want our numbers as decimals because it's a lot easier to graph them that way. So let's just kind of think about it. Usually I just sort of do some scratch work off to the side. Negative 1 times 3 is a negative 3. And then I have that 2 on the bottom. Okay, so negative 3 divided by 2 is going to give me a negative 1/2. All right, so when I get V prime, I'm getting a negative 0.5, or you can say 0.5. Okay, so moving on to positive 2 here. Again, 2 times 3 is going to give me a 6. And then that 2 on the bottom divides into it, divides evenly, so that's kind of nice. And we're going to get a 3. Okay, so moving on to U, same idea here. So getting U, negative 1, again, it's the same idea. Negative 1 times 3 is a negative 3. Negative 3 divided by 2 gives me a negative, oh, I did my math wrong before, huh? It's a negative 1.5. I thought that was weird. That's why I kept pausing. I was like, that 0.5 does not seem right. Okay, sorry, let's fix that. Negative 1.5 on this one. Same thing here, negative 1.5. I'm sure you saw me do that and you're like, oh, Mr. Stone, you're messing up. Okay, on this one, negative 2 times 3 is a negative 6. Negative 6 divided by 2 gives me a negative 3. All right, moving on to W prime. By the way, there's U prime, V prime. Okay, these are nice and easy. 2 times 3 is a 6. 6 divided by 2 gives me 3. And again, I'm going to get another 3 here. All right, moving on to X prime. 2 times 3 is a 6. 6 divided by 2 is another 3. And then negative 2 times 3 is a negative 6. Negative 6 divided by 2 is negative 3. Okay, so it didn't really require a calculator too much there, even though maybe I should have used one because I messed up. But again, if you run into some weird numbers that you aren't sure about dividing, just use a calculator. No shame. All right, let's plot them. So V prime, negative 1.5, positive 3. So to the left, 1.5, up 3. V prime. U prime, to the left, 1.5, down 3. So to the left, 1.5, down 3. There's U prime. Okay, W prime, 3, positive 3, to the right, 3, up 3. Easy enough. And X prime to the right, 3, down 3. All right, so taking a look at our shape after we connect our dots, it looks like we got an enlargement. Okay, here's something to look out for. Some students think, oh, if it's a fraction, that means it's less than 1, right? Fraction, oh, those are, decimals. No, this is, 3 divided by 2 is a 1.5. Okay, that is a number greater than 1. We should have expected an enlargement. Okay, all right, let's try another one of these fractions and I'll let you do a couple on your own. All right, let's try one that's having us do a dilation of 1 over 4, 1/4. Okay, let's get these originals real quick. I'm going to start with E. He's at negative 4 on the X, 0 on the Y. Okay, F, negative 3 on the X, positive 5 on the Y. Okay, G, negative 1, positive 5. And H, positive 1 on the X, 0 on the Y. All right, and we're multiplying all of these by 1 over 4. Or just, by the way, if you want to just divide that now, a 1 over 4 is a 0.25. You could just multiply by 0.25 on all of these if it makes it easier. Okay, but let's see what happens. So when I go to get E prime, okay, negative 4. Okay, remember, we just multiply that number times the numerator and then divide by the denominator. Negative 4 times 1 is negative 4. Negative 4 divided by 4 is negative 1. Okay, 0 times anything is always 0. We don't need to overcomplicate that. Okay, so let's try out F. This might be the weird one here. So negative 3 times 1 is negative 3. So let me write this one out. And then we have that 4 on the bottom. So we're getting a negative 3 over 4. And again, if you need to use a calculator and divide those numbers, that's going to give us a negative 0.75. Okay, or 0.75, however you want to write it. Okay, same idea with this 5 here. 5 times 1 is going to give me a 5, so I'm going to get a 5 over 4 here. And when I divide 5 by 4, I'm going to 1.25. Okay, so there's F prime. Moving on to G prime. Okay, negative 1 times 1, negative 1. Negative 1 divided by 4 is negative 0.25. Okay, multiplying by 5, we did that before, right? So we know we're going to get a 1.25 here. And last one, H prime, multiplying by a positive 1. We know that's going to give us a positive 0.25. And 0 times anything is 0. Okay, so some weird decimals, but we got calculators, nothing crazy. But getting the graph correct is important. So let's break this down. E prime, pretty easy, negative 1, 0. So that means to the left 1, up 0. There's E prime. F prime negative 0.75. 0.75, that's 3/4 of the way. So I'm going to the left. There's 1/2. 3/4 would be right about there. And then up and 1/4. So about right there would be F prime. Okay, G prime to the left 0.25. So to the left 1/4. So about there. And then up 1 1/4. There's G prime. And H prime to the right 0.25. So to the right 1/4. And then, up 0. So right about there. All right, so this one's kind of weird, got some 0.25s and whatnot. But when we go to connect it, you guys can see it is, technically, I guess maybe not technically, but it is the same shape. It has just been shrunk, okay, which again, we should have expected because 1/4 is technically, 0.25. That is a number less than 1. We should expect a reduction. Okay, so I'm going to have you guys go ahead and try out numbers 7, and then you'll try out 8 afterwards. But start with number 7 there. All right, so again, I'm going to have you guys do this on your own, but we should expect an enlargement here. This is, 2.5. So we should expect you probably got something that looked, like this. All right, go ahead and try out. Oh, sorry. Go ahead and try out number 8 on your own. Do a dilation of 1/4. All right, so again, we should expect a reduction here when you're multiplying it. I'm just eyeballing it. It might not be like what I'm saying, but you probably got a shape that looks something like that, maybe. Okay, so yeah, that's the basics of dilations, guys. Not too shabby as long as you know how to multiply. It's a little weird when fractions get thrown in, but otherwise it's not that bad. Okay, so I'll see you guys back in class. Bye.